Good morning, children. And in the unit number 5, நம்ம various topics cover பண்ணிட்டோம். ஸோ எலக்ட்ரிசிட்டி எப்படி மேக்னெட்டோட ரிலேட் ஆகுது, எலக்ட்ரிக் கரண்ட்டை வச்சு நம்ம எப்படி மேக்னெட்டிக் ஃபீல்ட் ப்ரொடியூஸ் பண்ணலாம், தென் மேக்னெட்டிக் ஃபீல்டை வச்சு எப்படி எலக்ட்ரிசிட்டி ப்ரொடியூஸ் பண்ணலான்றது இந்த டாபிக். ஓகே, ஸோ வாட் இஸ் அப்ளிகேஷன் ஆஃப் எலக்ட்ரிக் மோட்டார் நம்ம பார்த்துட்டோம். அண்ட் த எஃபெக்ட் ஆஃப் த எலக்ட்ரிக் மோட்டார் கேன் பி இன்க்ரீஸ் வித் த சம் ஃபேக்டர்ஸ். இது எல்லாமே நம்ம லாஸ்ட் கிளாஸில் பார்த்தோம். And today we are starting with the topic electromagnetic induction. Okay, so in the electromagnetic induction பார்த்தோம்னா ரெண்டு சயின்டிஸ்டோட எக்ஸ்பெரிமெண்ட்ஸ் ரெண்டுமே ரிவர்ஸ் டு ஈச் அதர். ஸோ ஃபர்ஸ்ட் ஒன் வாஸ் எக்ஸ்பிளைன் பை ஆயர்ஸ்டெட். ஹி எக்ஸ்பிளைன் எலக்ட்ரிக் கரண்ட்டை வச்சு அந்த கண்டக்டரை சுற்றி ஒரு மேக்னெட்டிக் ஃபீல்ட் ப்ரொடியூஸ் ஆகும் அப்படின்னு ஆயர்ஸ்டெட் சொல்கிறாரு. So reverse effect of this in 1831, Michael Faraday explained we can produce the electric current with the help of magnetic field. இதை யார் சொல்றாருன்னா மைக்கேல் ஃபேரடே சொல்றாரு. It is just opposite to the first scientist who is called as Oersted. And these two experiments, these two demonstrations are milestone for our physics and our daily life. நம்ம லைஃப் இவ்வளோ கம்ஃபர்டபுளாக இப்போ நம்ம எவ்வளோ என்ஜாய் பண்ணுறோம். We can hear songs and we can talk using the mobile, internet, then watching TV, and everything is nowadays we are working with the help of electricity. இந்த எலக்ட்ரிசிட்டி இவ்வளோ ப்ரொடியூஸ் பண்ணுறதுக்கு ரீசனே பிகாஸ் ஆஃப் திஸ் எலக்ட்ரோமேக்னெட்டிக் இண்டக்ஷன். So to produce this electromagnetic induction, the magnetic flux should be changed in some ways. What are the ways we'll discuss in following experiments. Okay, so the experiments were demonstrated by the scientist Faraday. So first we'll discuss about experiment number 1. So for this experiment number 1, we are using the two coils. Okay, so say the coil 1, this is we are taken as 1, this is 2, and here two coils were wound on a soft iron ring, and these two are separated. See here there is a gap, these two are separated. Say this is first coil, this is second coil, and first coil is connected with the key, and here there is a gap. So this key is called as open key, battery in series connection, and second coil, two ends are connected with the galvanometer. So this second coil is connected with the galvanometer. Here it is used to check whether the electric current is produced or not in the second coil. For that we are using this galvanometer. Now we are starting our experiment. In first coil, the key is closed here. When it is closed, the electric current will be flow from positive to negative direction. In battery, the big terminal is positive, small one is negative. Okay, that you know, நம்ம அந்த symbolsல பார்த்திருக்கோம். So in this first coil, the electric current is flowing positive to negative direction. At the time, as per Oersted experiment, in the electric current flow coil, surrounding that some magnetic flux will be produced, some magnetic field will be produced there. நம்ம கரண்ட்டை வந்து மினிமம் டு மேக்ஸிமமாக இன்க்ரீஸ் பண்ணும்போது இட் இஸ் ப்ரொடியூசிங் த சேஞ்சிங் மேக்னெட்டிக் ஃபீல்ட், தட் இஸ் கால்ட் அஸ் ஃப்ளக்ஸ். And due to this changing magnetic flux, it affects the second coil, and also it is called as secondary coil. So some induced EMF or induced current is produced in the second coil. So how to confirm that some induced current is produced in the second coil அப்படின்னா, using this deflection of the galvanometer we can say. So when the battery is off, there is no deflection in this galvanometer. When we are on this battery, now some deflection in this galvanometer needle, then we can say in this coil number 2, some induced current is produced there, because you see here the first coil is connected with the source of electricity, but second coil it is not connected with anything, just it is connected with the galvanometer. It won't produce any energy. ஆனால் இது நம்ம ஆன் பண்ணால் மட்டும் எப்படி டிஃப்ளெக்ட் ஆகுது அப்படின்னா, தட் இஸ் பிகாஸ் ஆஃப் த எலக்ட்ரோமேக்னெட்டிக் இண்டக்ஷன். Okay, now experiment number 2. in this experiment number 2, see here we are using the bar magnet. So you know bar magnet generally all the magnets having the terminals of north and south. So here number of turns of the coil is taken. Inside that the magnet is moved towards or away from that, and these turns of the coil is connected with the galvanometer. Whenever the magnet is moving in between the turns of the number of turns of the coil, at the time this galvanometer shows deflection. If the magnet is moving down means it shows one direction. If the magnet is taken out in opposite means the deflection will be opposite. When we are increasing the speed of the magnet, the deflection in the galvanometer also, the speed of the deflection in the galvanometer also increases. It explains whenever the speed of magnet increases, the production of current in the coil also increases. இந்த galvanometer ஏன் டிஃப்ளெக்ட் ஆகுது அப்படின்னா, இந்த காயில் நம்ம மூவ் பண்ணுறோம்ல, அந்த காயில் ஒரு EMF அண்ட் இன்டியூஸ்டு கரண்ட் ப்ரொடியூஸ் ஆகிறதுனால தான் galvanometer's movement is there. Okay, and next is experiment number 3. In this experiment number 3, the magnet is fixed here, electromagnet is used here. Electric, okay, the magnet is fixed here, sorry, not electromagnet, simply coil is used here. Okay, and this coil is wound on a soft iron ring, and this is magnet U-shape or horseshoe magnet, we can say. This is north pole, this is south pole, and it is fixed here. This experiment is reverse of experiment number 2. அதில் நம்ம மேக்னெட்டை மட்டும் மூவ் பண்ணுவோம். இதில் பார்த்தோன்னா காயிலை மட்டும் will move up and down. So while changing the movement of this coil, because of changing magnetic flux, some deflection is there in this galvanometer. That is because of the changing magnetic flux. This is the reason for electromagnetic induction. And here in all the 3 experiments, the produced current is called as induced current because of the influence of some other coil or some other magnet. And this is induced current. This induced current direction we can give with the help of Lenz's law. So what Lenz's law is explains is, magnet இல்லை நம்ம மூவ் பண்ணுற ஆப்ஜெக்ட் எந்த டைரக்ஷன் மூவ் ஆகுதோ அதுக்கு ஆப்போசிட்டில் induced current produce ஆகும். This is called as Lenz's law. And also we can use Fleming's right hand rule to explain this induced current, the direction of the induced current. Okay, and now see scientist Michael Faraday, between 1791 to August 1867, he was a British scientist. He gave famous law which is called as electromagnetic induction, and also he is famous in diamagnetism and electrolysis. Okay, next topic is Fleming's right hand rule. So it is also like Fleming's left hand rule. And right hand, first 3 fingers, thumb, 4 and middle finger, have to stretch perpendicular to each other. And here the thumb finger will shows the direction of motion of a force, and 4 finger will shows the direction of magnetic field, and middle finger will shows the direction of induced current. This is called as Fleming's right hand rule. And this right hand rule is also called as generator rule, because this rule we are applying for generator. Okay, so after this Fleming's right hand rule, here we will discuss about electric generator. And the construction, the function of electric generator we will see using the diagram. And see the diagram, this red color is denoting the north and south. In small generator like cycle inverter, there we are using dynamo now. So that dynamo will be function under the movement of the cyclic tire. So there we are using fixed magnet. And in huge generator we can use the electromagnet. Okay, somewhere we have to use 2-pole magnet, and between the magnet we are having the armature. This armature is fixed with the axle. Okay, some axle is fixed there, so that axle will be rotate. So about the axle, that armature ABCD also will be rotate in between the 2 magnets. Why this armature is rotating means it should produce the changing magnetic flux between the north and south polarity. Okay, and now it is whenever the ABCD is rotating, there is a production of magnetic field. And now the edge of the armature is connected with the S1 S2, that is called as 2 slip rings. Okay, and inner sides of these rings are insulated, so it won't affect because it is well insulated. And 2 brushes B1 B2 are given in this generator. It is called as brushes These two brushes are kept separately and the rings S1 S2 respectively, and these axle mechanically rotated means the armature is also rotated in between the magnet. So this rotation will produce the magnetic flux, and already this armature is won by it is the soft iron core. It is having large number of turns on this soft iron core. So whenever it is rotating, and because of this north and south, some magnetic flux is changes on this armature, it gives the induced EMF in that coil. Okay, so when it is producing the induced EMF, we can give the direction of the induced current in that coil with the help of Fleming's right hand rule. So you know that is also called as what? Generator rule. When ABCD armature coil in the outer circuit flows from B2 to B1. So when the electric current, the direction along DCBA means we can draw the current from B1 to B2. Okay, and to get a direct current, a split type of commutator must be used. Okay, here it is rotated along with the axle, and when we are using the split type means, and there we can get the DC current, and here we explained this generator will produce the AC. So this type only we are using in windmill and hydroelectric power plant, etc. In many places we are using this kind of generator. So about this detail you will study in higher classes. And see, the AC and DC comparison is given. In AC, the brushes S1, B1, B2 is shown here, but in DC the brush is splitted with the commutator. Okay, this is about AC generator. And next one is transformer. ஸோ டிரான்ஸ்ஃபார்மர் பார்த்தோன்னா நம்ம ஏரியாலேயே நம்ம வீட்டு பக்கத்துலேயே ஒரு ஊருக்கு ஒரு டிரான்ஸ்ஃபார்மர் இன்ஸ்டால் பண்ணியிருப்பான். தட் டிரான்ஸ்ஃபார்மர் யூஸ் இஸ் ஸ்டெப் டவுன் ஆர் ஸ்டெப் அப். ஓகே, ஸோ த மெயின் ஃபங்க்ஷன் ஆஃப் த டிரான்ஸ்ஃபார்மர் இஸ் ஹை வோல்டேஜ் கேன் பி கன்வெர்ட் இன் டு லோ இன் ஸ்டெப் டவுனில். பட் இது வந்து நம்ம வீட்டுக்கு இல்லை இண்டஸ்ட்ரிக்கு யூஸ் பண்ணுறதுக்கு. ஆனால் எங்கே எலக்ட்ரிக் பவரை ப்ரொடியூஸ் பண்ணுறாங்களோ அங்கே வி ஹாவ் டு ஸ்டெப் அப். தேர் த லோ வோல்டேஜ் ஷுட் பி கன்வெர்ட் இன் டு ஹை voltage to avoid the power loss while it is transmitting from production point to consumer point. Okay, இந்த டிரான்ஸ்ஃபார்மரில் என்ன ரூல் நம்ம யூஸ் பண்ணுறோம், என்ன பிரின்சிபல் யூஸ் பண்ணுறோன்னா electromagnetic induction. So what rule we are using here? Electromagnetic induction. In this transformer we can work with AC only. Okay, because this AC flowing through the primary coil induces the magnetic field in the iron ring. That iron ring induces varying EMF in the secondary coil. So the input current does not have direct contact with the secondary. Through the iron core only this transmission will be happens. In step up, 110 or 120 is converted to 220 or 240, but in step down it is reduces to 110 or 120. So these two kinds of transformers we are using. So first we can convert step up and step down with the help of number of turns, and we'll see the step up transformer. When the voltage, the secondary voltage is greater than primary means that is called a step up. In this step up, the number of turns in the secondary coil must be greater than the number of turns in the primary. In step down transformer, it is just reversed. Vs is lesser than Vp. So what is Vs? Voltage in secondary is lesser than voltage in primary. This we can done with the help of number of turns is lesser in secondary and number of turns is greater in primary. We can achieve the step down transformer. Okay, and do you know a step up transformer increases the voltage but decreases the current, because to avoid the loss of energy in the format of heat and sound, vibration, etc. And the formula we are using for the transformer, number of turns primary divided by number of turns in secondary is equal to Vp divided by Vs, that is primary voltage to secondary voltage. Or we can write number of turns in secondary divided by number of turns in primary, that is Ns by Np is equal to primary current divided by secondary current, that is Ip divided by Is. A transformer can be used only by the AC. We can't use DC because this DC there is no change. It won't give any change. So the magnetic field will not link with the secondary. So when if you use DC means the net effect in output is 0. Okay children, so have you understood about transformer? Now the problem 3 is based on the transformer. The question is, the primary coil of transformer has 800 turns and the secondary coil. So the primary coil 800 means NP, secondary is NS 8 turns, connected to 220 voltage of AC supply. What will be the output? So EP is given, output means that is ES, and here the formula ES by EP is equal to NS by NP. We need ES, then you send the EP to right hand side, cross multiplication, then NS by NP into EP, substitution, then we are solving, the answer will become 2.2 voltage. Okay, and next is applications of electromagnet. There are a lot of applications, the engineering level and sound, music, so everything is working under this electromagnetic induction. And now we'll see some applications. Speaker, inside the speaker we are using the electromagnet in front of the permanent magnet. When the permanent magnet is fixed firmly in a position, whereas the electromagnet is mobile, it can move. As pulse of electricity passes through the coil of electromagnet, the direction of magnet rapidly changed. In turn, it produces to and fro movement from the permanent magnet, vibrating back and forth. So this electromagnet is attached to the cone made with a flexible material such as paper or plastic. It will make a vibration, and that vibration is producing the pumping sound waves that is transmitted through the air, and it will be reached to our ears. So this is a function. So in this speaker, two magnets we are using. One is fixed magnet, around that electromagnet. So this electromagnet, what type of electromagnet? It is mobile. Okay. Next, magnetic levitation trains, or we can say maglev. This magnetic levitation is a method that is suspended with no support other than magnetic field. So here the magnetic field only supporting here, and here two sets of the magnet are used here. One set is used to push the train up of the track, and another one set is used to floating the train, and it is moving in forward direction. Without friction it is moving. So also this type of train can move more faster than ordinary train. This is the application, this basic principle in this is principle of magnets. Here we are using the electromagnet. And next is in medical system, in MRI scanning to see our inner organs of our body. This method we are using, and it is used to give a treatment for cancer, implants, and magnetic resonance imaging. And this device, which is used to produce the very low temperature, and magnetic lines are allowed to pass through our body, it can penetrate, then it can use to take the scan of our inner organs. And many other medical equipments such as scanners, x-ray equipments, and other equipments also use the principle of electromagnetism for the functioning. So there are huge applications are there. So till to invert the electromagnetic, actually we should say that is discovering the electromagnetism. The development of physics is very less, but after that it gave more applications, life oriented. In many ways it is sophisticated to our life. So we can say this electromagnetic induction definitely a milestone in our physics. It's like a diamond in our physics. Okay, and children, this unit is over, and for today's homework, mark this transformer, answer from here then up to here including everything. Okay, so right question, explain the construction and working of transformer. This is your homework question. You thorough this answer with these two diagrams, then you write this in your homework part, then you take that photo and you send that image to my personal WhatsApp number. Okay, thank you children.